Hi, the chapter 7, the multinomial data. So we think about the categorization problem. So typical example is character recognition problem. So based on the handwritten data, that is maybe the 24 times 24 pixel data. So that is 576, the 24 by 24 variables. So 576 the dimensional variables, and each data that corresponds to the one of the 9 numbers, so 1 to 9. So rather than the just binary model, that we have the 10 categories, and we have to classify each picture into either 0, 1, 2, or 9, up to 9. And another example is the movie rating data. Maybe based on some basic information about movies, such as the length or the main actor or the genre or some other things, then the customer rates that movie from 1 to 5. So in this case, these 1 to 5 are ordered. So 5 is better than 4, and the 4 is better than 3, and so on. So this is the ordered data. So we think about this kind of the categorization problems. Yeah, so this is this is mathematical setting. So let y be multinomial variable. So that is the possible values are either C0, C1. Maybe we should avoid the C0, and a C1, C2 up to CJ. And categories may be the nominal, such as the countries or the characters A to Z, or ordinal, the rating in the scale of 1 to 5. And we can express this y as a j-dimensional vector y1 to yj. So for example, the character recognition problem, suppose the y corresponds to 3, category 3, then we can express that as 0, 0, 0, 0, 0, 0, 0, 0. Okay, so this is a place of 3. So think about the first one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 3 can be expressed as this vector. So just the indicator, the place of 3 is 1, and the other places are 0. So in this case, this the yj. So this is the y1 to yj. So the summation of y1 to yj is equal to 1. And the yj is equal to 1 means the y is categorized as the jth class. And some data are more complicated. So sometimes the ith line, the ith data point, includes the information of ni multiple individuals. For example, the movie rating by 5 people. So maybe 3 people voted as 5, and 1 people voted as 4, and the other voted as 3, or something like that. So in such a case, the summation of yj is equal to 5. So summation of yj is in general equal to n sub I. So it depends on the ith observation. Yeah. So so the example, the result of survey rating from 30 customers, ni is equal to 30. And yj is equal to k means that the k customer that choose the category, the C sub j. Yeah, so in general, the yij, so yij is the number of individuals in the ith observations that falling in the category j. So this is represented as the probability distribution of y sub ij's are represented as this. So okay, so this is multinomial distribution. So so this is the basically ni choose the y1 yi1 to yij. So for example, if the ni is equal to 6, and okay, so we have 3 categories, and the yi1 is equal to 3, and yi2 is equal to 2, and yi3 is equal to 1, then this is the 6 factorial divided by 3 factorial, 2 factorial, 1 factorial. Oh, yeah. So this actually in the textbook that there is a typo and this factorial is missing. Okay, so then this probability. So for example, the first one has probability of 0.5, second one the 0.3, the third one 0.2. Then that means the probability 0.5 happens 3 times, the 0.3 happens twice, and the 0.2 happens once. So this is the probability. So 6 factorial is so product of 1 to 6, so 720. So divided by the 3 factorial times 2 factorial, so 12, so that is 60. So 60 times the 0.5 to the third power, 0.3 square times 0.2. So in this way, that we can calculate probability of yi1 is equal to 3, yi2 is equal to 2, and yi3 is equal to 1. So this is the setting of multinomial models. And this is just an overview of the chapter 7. So we have the 4 sections. So the first 3 sections are categorical, just nominal. And the last section is ordinal. So ordered data we think about. So ordinal data has more structure, so it's slightly more complicated. And the first one is the multinomial logit model. So this is an extension of logistic regression. So linear discriminant analysis. This is a little more basic thinking about the categorization and the hierarchical model. So this isn't very new, but if some categories, a few categories are nested in one larger category, sometimes we need the 2 steps to analyze the entire categories. So just explanation for that. And the 7.4, still that we use somewhat similar to logistic or probit models, and the model we study models which can be applied for ordinal models.